Ooh woo! Today's about inverse trig derivatives. Let's go. Oh, I did have a Kahoot. Oops. Oh well. Hey, what's an inverse trig function? So, what do you have to know for an inverse trig function? So, you know the trig functions like sine, cosine, tangent, and so on. Well, we have the inverse of these functions, and we call these like arc sine or arc cosine or arc tangent. They have arc in there. Why does it say arc? I don't know. So the idea is that if I say y equals arc sine of x, then sine of y equals x. Another way of saying this, I hate how they write it like this. If I went sine of x equals y, the arc sine of y equals x. It's kind of reverses it. So another way of saying that is like, you know how sine of square root of 2 over 2? No, not even square root of 2 over 2. Jeez, I'm getting this wrong. But I'm not going to redo the video, that's for sure. Sine of pi over 4, like pi over 4 in the unit circle, so like the halvesies. That is going to equal square root of 2 over 2. The arc sine of square root of 2 over 2 would be pi over 4. So it flips those. Sure. Now, another way of doing arc sine is doing like sine to the negative 1 of x. That means inverse sine as well. Or cosine negative 1 of x. And I think that's what I mean by alternate form. Say y equals sine negative 1 of x. Y equals cosine, inverse cosine of x, or y equals inverse tangent of x. The problem is I hate these notations because they don't mean 1 over tangent of x. It doesn't mean reciprocal. Like if I would have done negative exponents for like polynomials. It doesn't work that way. So I don't like writing the negative 1. But sometimes that's less writing. So I don't care what you do, but don't get confused on those. All right. So it's about flipping it. And what does that mean? So, there's other information about this. I don't know if this is relevant. Actually, do they do that? Do I do it with a picture? Okay. So a few of the things that might matter when we can do an arc sine. So when we do the domain would be negative 1 to 1. And just think about this, like on the unit circle, the spots go from negative 1 to 1, right? I think you can pretty much understand this. But one thing we have to watch is these range of values. So when I'm dealing with arc sine, the range of the y values go from negative pi over 2 to pi over 2. And same thing with tangent. And then domain of arc cosine is 0 over pi. Now, this table is confusing to me. So I like doing it in graphical form. I don't explain it this way. So here's the domain when you're dealing with unit circle. When you are dealing with sines and cosines, oops, I'm not switching that pen. This pen. I'm dealing with sines and cosines. I am going to be dealing with this side of the circle. So see this? Oh, the right half? This is going to be the domain for, let's say, arc sine and arc tangent. This is like the area of the unit circle that you go to. And so we're going to say this is negative pi over 2 to positive pi over 2. So you're dealing with answers have to stick within this domain, okay? This region of the unit circle, negative pi over 2 to pi over 2 for sine and tangent. Now for cosine, it only deals with the top. So cosine arc cosine is going to deal from 0 to pi. So sometimes that matters if you actually have to plug things in. And the reason why this matters is because things become, we have coterminal angles. Because really, negative pi over 2 is the same thing as 3 pi over 2, which is the same thing as like 7 pi over 2, whatever, and keep going. So you're only dealing with these domains. So if you have to plug in certain values, that's something to remember. For the purpose of this class, I don't think it matters too much, unless you actually have to plug in numbers. But I don't think this like calculus goes too deep into that stuff. But I just wanted you to know that cosine is the top, sine and tangent are the right. I don't know. Did you remember that from last year at all? From any of this stuff? Does that seem familiar? Any of you? Already zoned out. Nice. Maybe. All right. So I just wanted to show you. I mean, this is like pre-calc right here, right? So if I wanted to solve some of these. Oh gosh, I hate doing tangent. I hate trying to explain this. Because no one ever just like tangent of 1. What does that mean? Let's do cosines first. When I say arc cosine of -1, what I'm really asking for is cosine of x equals -1. When does cosine equal -1? I'm going to think about it that way. What? And now you go to a unit circle. Cosine's the x values. It's going to equal -1 right over here on the right side. What is the angle right here? Well, that's going to be pi. My answer for B would be pi. Now, and here's why domain matters. Let's say for this one. So this is like saying sine of x. Where does sine equal -√3/2? The sine's the y values on the unit circle. You know you have like the 3 spokes right here, right? I don't know. I think of it that way. So, and -√3/2, like one of these is going to be -1/2, -√2/2, and -√3/2. So this one's going to be the lowest one, which is going to happen right here and right here, because it happens at 2 points. And this coordinates to this point on a unit circle, you would usually call this one 4 pi over 3, and you'd call this one 5 pi over 3. All right? But my answer is not 4 pi over 3 or 5 pi over 3. This is where that domain matters, because I'm dealing with the right side, right gang right here. And 5 pi over, and the right gang has to go from pi over 2 to negative pi over 2. So I'm not going to use my answer. So then you might say, oh, the answer is 5 pi over 3. No. What's coterminal to 5 pi over 3? And within that, within this domain or range or whatever we want to call it, that would be negative pi over 3. Kind of see that, maybe? Okay, so let's walk through this. So one thing you need to understand. Oh, I can't show the work again without erasing. And I can erase. Okay. The one thing you have to understand is this side of the unit circle, whenever I'm dealing with inverse sines and cosines, is going to be dealing with sines and tangent. We're only dealing with sine, cosine, and tangent for inverses for the purposes of our classes. All right? Not cosecant, cotangent, or secant. Just these. It's going to deal with the right side right here, and that's a domain of going from pi over 2 to negative pi over 2. That's negative pi over 2. So your normal unit circle, we'd say, this is 0. This is pi over 6, pi over 4, pi over 3, pi over 2. And then I can keep going. 2 pi over 3, pi over 4, 5 pi over 6. Maybe I should have made you do a unit circle at the start of class. Oh, well. That's a pi. This one right here is going to be 4 pi over 3. No. It's going to be 7 pi over 6. This is 5 pi over 4. This is useful to memorize. You haven't. 4 pi over 3. This is going to be 3 pi over 2. 5 pi over 3, 7 pi over 4, and this is 11 pi over 6. Okay, I've done this forever. That's why I know this. Now, usually on the unit circle, we'd say these angles. But for the purposes of the domain where we're talking about inverse, tangent, and sine, angles are also coterminal. So while this is 3 pi over 2, it's also negative pi over 2 if you worked backwards for coterminal. Okay. So what I'm saying for my domain here, I'm going to go from negative pi over 2 to positive pi over 2. So while this is negative 3 pi over 2, it's also this. This angle right here would also be, well, let's start from 0. This would be negative pi over 6. This one would be negative pi over 4, kind of mirroring what's happening here. Okay. That's okay. Well, there's another visual. Cool. Now, for cosine, cosine doesn't change any of that weirdness. It's just 0 to pi. All right? It's just the same, but you're only dealing with the top. So why this matters, and this is the problem, kind of similar to the problem I just did. Let me give an example of why it matters. If I said, find arc cosine of, I'm going to say, negative 1/2. Okay? Well, that's like saying, let's say I said, that's like saying when find cosine of x, find x when cosine is equal to negative 1/2. I'm kind of like reversing these, saying what is the angle of cosine when cosine equals 1/2? No way. So you're looking at your unit circle. That happens at this point and this point. So if I asked you this equation right here, there would be two answers on the unit circle. Boom and boom. You might not know which one to pick, or you might pick both. But when I'm asking this way, you're only picking what's in this domain. So your answer is going to be pi over 3. So will that matter for this class? I don't know. Kind of get that? Maybe. Maybe that's better. So that's what I was doing on this one. So again, with sine of 3 pi over 2, that's like saying sine of x equals negative square root of 3 over 2. If I go back to my unit circle, which I can't now because I messed it up, that happens at this point. Oh, wait. And this point. The angle right here, because on normal unit circle, would be 4 pi over 3, and this one would be 5 pi over 3. However, we're only dealing with the right side, so we're not dealing with 4 pi. We have to do coterminal to this, which would be negative pi over 3. It's weird, and it's something you might have vaguely done in pre-calculus. Let's talk this arc sine of 2, though. So what's arc sine of 2? Let's say sine of x equals 2. When does sine equal 2? Never. Correct. Because the unit circle goes from negative 1 to 1. So kind of a trick question. Haha, got you. Now, arctangent of 1, where does tangent of x equals 1? No one has these memorized, or most people don't. But that happens at the halvesy point here, pi over 2, or pi over 4. And it happens at the halvesy point here where it's negative at 5 pi over 4. Well, you're dealing with tangents the right side, so this would be pi over 4. Kind of get that, at least just to show you how to do those. I don't know if it's going to be important for the lesson, but maybe you get this. I don't want to harp on this too much, I don't think. Salcon may make you to do more of this, though. Okay, I can solve this equation here. Why not? So if I had this, I'm going to rearrange it and say sine of pi over 2 equal to x squared minus 3. Now, sine of pi over 2 happens at the top, right up here. That's going to equal 1. Add 3 to both sides. Square root both sides. X is equal to plus or minus 2. Now, is it plus 2 or is it minus 2? The answer is it doesn't matter. It's both. It would not matter. I think it wouldn't matter. Yeah, it wouldn't. We're doing algebra in here. Fine. It wouldn't matter. All right. Now, this is the important part. That's all pre-calculus. The reason we do this is the derivatives of the inverse trig, and we only have, 3 of these. And this is something like you memorize and then you forget right after this class, right after the test, I think. They're very similar. The difference here is arc sine is positive. I wish I had like a little mnemonic to memorize this or a song to play. I don't have a song. But the sine is the one that's positive. And now cosine looks the same, but this one is going to be negative. An arctangent is the one there's no square root. There's no root. And then you add them on the bottom. So what I would know is, I don't know, it's one of those things you just memorize. It's kind of lame. Don't have a way to memorize it better. I hate saying just memorize these, something you barely use, but there you go. Everyone is here except Skylar. Yep. All right, so what does this mean? Let's do a problem. Differentiate. So, hey, we're just applying chain rule. So derivative arctangent is 1 over 1 plus x squared. So g prime of y would be 1 over 1 plus the inside squared. Yes, you're writing this down. Okay. Welcome, class. Today we're going to differentiate. Arctangent. Anyone need these formulas still? Maybe. I updated grades too. Hope you check those out. And yes, you can make up things, but it's going to be really annoying for me to go back too far. I'm going to probably tell you to let me know at some point. Yeah, if you're really behind on Khan Academy stuff, man, you better catch up. You got a lot to do. Oh, I didn't grade the College Board stuff. That's what I didn't get to update. Hate that assignment. Oh well. Okay. So for arctangent, I know it's tangent. It's 1 over 1 plus x squared. Your inside is this thing. So your g prime be 1 over 1 plus the inside squared times the derivative of this, which is just 2. I know it says y, but we're not going to go times dy dx. Not a differentiation one. You can just leave it like this. You like to write it 2 over 1 plus 2y minus 1 squared? Sure. Could you expand those out? Sure, but why? I don't need you. Actually, could you? 1 plus, this would expand out to 4y squared minus 4y plus 1. Oh, watch this. And then it goes to 2 over 4y squared minus 4y plus 2. That means you could cancel out a 2 from everything. It's the same thing as 1 over 2y squared minus 2y plus 1. I don't see how that helps me, though. So I would leave it like this or like this. Okay, 8. Arc sine. So then I like assign the negative or the positive one. If you don't know, flip a coin. Or go back. It's the positive one. So it's going to be 1 over square root of 1 minus square root of x squared. Times 1 over 2 square root of x. That's the derivative of the inside. I don't want to do. Why don't you do these? You get water. I'm going to get up. I've been sitting down way too long. I'll be back. Let's see you try these. All right, let's do this. Cosine. The cosine is the negative one. Right? Sure. So derivative of this would be negative 1 over 1 minus ln t squared times the derivative of 1 over t. That's ln. Done. Number 10, simplify. Sine is the positive one. So 1 over square root of 1 plus x squared. So 1 over the square root of 1 plus x over 2 squared. I'm actually going to simplify this. And then times 1/2. And you're like, what do they mean by simplify? I would never make you do this, but I'm going to show you what they mean. So this is like 1 over 1 plus x squared over 4. And what we do is we don't want fractions in fractions. So I'm going to rewrite that, ignoring the 1/2 for now. is I'm going to change this to like 4 over 4. So it's 1 over square root of 4 over 4 plus x squared over 4, which you combine those fractions to 1 over square root of 4 plus x squared over 4, right? And then you can write that as 1 over square root of 4 plus x squared or square root of 4. Which is 1 over 2. 2 can go to the top. 2 over square root of 4 plus x squared times the 1/2 above. Those cancel out. And then you're left with 1 over square root of 4 plus x squared. So that's what they're looking for. Whatever. Honestly, folks, I'll never make you do that. And you don't need to for an AP test. But there it is. That's all I got for you.